Right. Hello. So I'm Robin. This is Timo. And we have Half-Shot joining us virtually. We're all from Element's VoIP team. And we're here to tell you all a bit about Matrix RTC and how to build real-time applications on top of Matrix using this. So you all probably know what Matrix is, but it's worth restating that today Matrix's primary use case is instant messaging. But Matrix really has ambitions to cover all kinds of exotic communications use cases, starting with voice over IP, but then extending possibly to virtual reality, augmented reality, the Internet of Things. So let's take a moment to talk about what Matrix is good at today and what building blocks it provides. So today we have primitives that, are good at enabling these near real-time use cases like instant messaging. And so some of the primary things that it gives us are when you're in a room, you have a room timeline, which represents the sequence of events that have happened there. And due to decentralization, this isn't just a strict order, but you actually get an acyclic graph. And so you have to think about what happens when the order of events isn't clear. But if you want to use this for really streaming data quickly in real time, well, you can get sub-second latencies, perhaps if you're exchanging data locally just on one home server, or in some cases over federation. But often over federation, you're going to start seeing latencies that go beyond the 1 second margin. And especially if you want to be doing things like streaming voice and video, putting this into a room timeline event really doesn't make sense, because the room timeline is for things that are meant to persist indefinitely. And the other important thing that Matrix gives us is room state, which is a summary of events that have happened in the room as basically a key value store. And so these are great for building instant messaging, but what's missing is if you want to do things like VoIP, like whiteboards. We're missing a way to actually communicate in real time with low latency, low jitter, and exchange data that might be more ephemeral in nature. And right, so let's take a brief moment to go over the ways that we've tried to do voice over IP in Matrix in the past. For the voice and video call use case. So ever since the start, there's been the idea that we could just use Matrix as a signaling layer for WebRTC and establish peer-to-peer WebRTC connections for doing these one-on-one calls. And what you do is you just take STP offers and you'd exchange them in the room timeline. And this is great because it automatically takes advantage of Matrix's encryption primitives, and so you pretty easily get an encrypted call working that way. But this just it's not a group call. And so when we thought about how are we going to make group calls work in Matrix, the first idea was maybe we can just use some off-the-shelf solution that already scales really well to hundreds of participants, such as FreeSwitch or Jitsi. And so Jitsi in particular was integrated as an iframe, as a widget that would just be rendered within your Matrix client. And then we thought about, well, what if we want to make this a more native experience, actually integrate it in with Matrix, and try to bring back some of leveraging Matrix's encryption. So that was why when we were working on the first iterations of Matrix RTC, we thought about maybe we can just take this simple one-on-one WebRTC setup and actually just generalize that to connect to more peers. And so you could have group calls where you're just routing your media to your peers in a full mesh configuration. Every peer connects to every other peer. And so this works. You get group calls and they're encrypted. You're communicating. You're just communicating your STP over two device messages that are in private channels, and they're encrypted with OM. But it doesn't scale, of course, because most internet connections that users are on, they're just not going to have the upload bandwidth to be able to send your local video 10, much less 100 times over to all the other participants. So what we really needed is something that was as ready to ship as an off-the-shelf solution like Jitsi, and that could scale as well as having a conference server that can sit in the data center and have a better internet connection. But also a solution that we can still tightly integrate with Matrix so that we can check this encryption box as well. So we were really looking for an SDK. And we kind of found exactly what we were needing in the form of LiveKit. So LiveKit is a company that's building open source solutions based on WebRTC for enabling all kinds of real-time applications. They develop an SFU, a selective forwarding unit, based on Pion, which is an open source WebRTC framework written in Go that was exactly what we were considering using when we thought briefly about writing our own SFU that would be more native to Matrix. So it's like if we don't want to reinvent the wheel, we should just use LiveKit. And so LiveKit provides the concept of rooms and participants. And for Matrix RTC, we wanted to have the concept of sessions that you can establish and advertise in Matrix, and then just session members, the ability to join these things. And so you kind of just match up the IDs, and this is how we set about integrating the two. Right, and then think about, well, how are we going to advertise exactly in Matrix that you want to be joining a call in LiveKit? So how do you advertise that you're in a call? Well, here it makes sense to just use the room state, as opposed to, in the past, we've been using room timeline events for things like the one-on-one WebRTC calls. It makes more sense to use room state because then it's very easy for clients to look up. They always have a copy of the most recent values of room state. Right, and then for if you want to ring someone else's device, well, there's another Matrix primitive which, or just thing that Matrix provides that makes a lot of sense here, which is to use an event that contains mentions, or contains intentional mentions. And this will push a notification, and then you have data such as just what session you're joining in the first place, some repeated information about the member that is joining in particular, and then the active LiveKit focus that she's going to be joining over. And then when she wants to send a notification out to perhaps ring other people's devices, this is what that looks like. She's just sending an MRTC notify event which contains intentional mentions. So just by setting this room true, this is automatically going to be pushed as a push notification to everyone else in the room. And then finally, when you want to leave the call, that's another simple state event update. You just set your member object to an empty object. Right, so those were some of the fundamentals of Matrix RTC, with the exception of encryption, which kind of deserves its own talk. And so I'm not going to attempt to cover that here. There was a great presentation from Timo at the Matrix conference in 2024, if you want to go look up the details of that. But basically, we want Matrix RTC to be a fully featured call solution with all the bells and whistles that you might need for creating a consumer-grade video calling experience. And so now we're going to, let's see. Is the video output going to work?
Is it going to work?
Well, that's a good question.
Oh,
Well,
yeah.
Aha.
not one
This looks
slack, that
promising.
must be good.
Perhaps. I think this is not seated properly.
Right. Definitely does something.
Well, there's the other one.
Uh-huh.
Yes. Nice.
There we
So
go.
we just do mirror, or
Oh, yes. Yes, we can do mirror. Okay.
Very hot shot.
Right, so now we have Halfshot joining us live, and he is going to demonstrate a little bit about what it looks like for these raise hand and reaction features that we've recently added to the product, or to Element Call, which is a video calling application implementing Matrix RTC, what those things look like. Right, I suppose we don't have the slides up.
so you can ask him Hafshot, can you share the slides? We're kind of putting him on the spot.
Okay, next slide. Right, so we had this really great contribution from Milton of Nordic earlier in 2024 of adding the ability to raise your hand in element call. And the way this works is really cool. It's just using a reaction event in Matrix. So we're just reusing that same thing that Matrix gives us, and you relate it to your call membership event, and then we render it in the call interface. And next slide. Right, this is what that event actually looks like. We have the relation and the key, I suppose. Yeah, it's just a hand, and yeah, it's just a standard reaction. Next slide. Right, then we also wanted to add emoji reactions to element call as well. Now these are a little different from normal reactions in Matrix because you might want to send the same emoji over and over again, whereas reactions you can kind of just add and remove them from an event. You can't send the same reaction twice. So we ended up creating a custom event type for this, which we will hopefully go back and spec sometime in the future. That's what they look like when they're rendered. And they have sound, which is just not playing. But yeah, next slide. And this is, yeah, just showing that they are completely normal. These aren't the standard reaction events, but it's using completely normal relation semantics. So just referencing your membership event, and then you send the emoji. Okay. Thank you, Hafshot. I think we're going to speed things along.
See how quick the switch now is?
Put it for you.
I think it is, right?
Mm-hmm.
Is it doing something?
There we go.
Oh, perfect. Yeah, I can just move it over real quick then.
Right, it's this that needs to be moved over.
Oh, perfect. Yeah.
There we go. And here. Perfect. Right, so as I was saying, Matrix RTC has ambitions to be for far more than just voice over IP. That's like why we refer to these as sessions rather than calls. But I wanted to highlight a couple of the ways in which Matrix RTC aims to be extensible. So we have this application field when you're joining a session that you can specify exactly what kind of data you expect to be communicating over the RTC session in the first place. So you might use this to, you could chuck in any namespace identifier and use this to build a whiteboard experience, a word processor, what have you. And you also might want to consider like integrating, or we might want to integrate a third-party callback into the future. And so a way you might do this is just changing up the type of the active focus. And this is how you might integrate or just signal that you're using a Jitsi focus rather than a LiveKit focus. Right.
So I take over now and then starting with saying that this is something we, like if you followed along the Matrix RTC project, we've advertised since a long time. Like this extending with different kind of applications, they're all RTC with the same architecture. And now we are finally at a state where we are confident in our current SDKs, and we can show a demo on how this is actually done. So what will come next is a demo where we built a Matrix RTC application with the current SDKs, which does all the specified things, send a state event into the room, connect to the LiveKit SFU, but it does something other than calling. So I'm again in this like slightly odd situation where my screen is extended. So I do my best, but the mouse might be like a little less coordinated than what it would be if it's on the same screen. So what I've prepped here is, is a project that is basically just a Matrix widget. This is cool because then I don't need to care about encryption and like authentication. So I'm in one room, like this M room, with two accounts. It's actually the same account in this case, but two different devices. I also could have used different accounts. would make any difference. And in this widget, I'm now starting a Matrix RTC session. So I'm joining the RTC session. Element Web should detect this as, oh, there's an ongoing session. It now thinks it's a call, but it's a different type. And then it will automatically build up a RTC channel over LiveKit. So this is all just Matrix RTC infrastructure. There's no backend running on my computer. And we'll have like a little demo of like a real-time experience. So I start here first. It says it's connecting. And now it's connected, and we can see this client is actually detecting there's something real-time going on. It's a little annoying because it's doing both, like syncing the coordinates, and so we have the name in the background. So yeah, you can really tell this is just like a tiny demo, which was done in more hours than days. And then we have a maximize button, so we really can do all the things like write text, put it into a box, and edit it, and then move around the frame if I would remember how to do this. I don't, apparently. But, oh, yeah, there it works. So you can do all those kind of things, and they're all synced in this like smaller frame. And then if we're done, we can leave on this side and minimize here. Okay, that's like a little broken. Probably would look better like this. Minimize here and leave on this side. And it will detect that the RTC session is over. I should like clean up this frame also a little bit, but that's basically our minimal product, how we can do, or any of you could do with just a couple of lines, a RTC app where you don't need to care about any backend implementation. You have an end-to-end encrypted with an asterisk, because there's a little bit of work on this side needed, and where you have an end-to-end encrypted real-time experience for, yeah, anything. So this will be on GitHub eventually. I think I will just do a TWIM announcement. So if you are interested in such a thing and want to build one yourself, should be possible in the next couple of weeks when everything is published. Cool. So then I give over to you again, right?
Yeah. There you have it.
And I'll try to get the slides again.
Custom real-time experience built on Matrix. Okay, and now with whatever amount of time we have left, I would like to just go through a few things that we have in mind as possible next steps for Matrix RTC. So one question is like, where do you put metadata about a call, such as just which LiveKit instance to connect to? We previously were like putting this in a state event that just describes information about the whole call, but then because of the ownership issues, we switched to a situation where everybody proposes their own LiveKit instance, and then clients are just running a simple algorithm that is selecting whatever the oldest membership is, or converging on their LiveKit instance. But in order to align better with our desire for this to really be a federated solution, we might want to enable clients to just publish their media on their home server's own LiveKit instance, and then have everybody in the call connect to all of the LiveKit instances involved and fetch media from them, so that you're really never converging on a single instance, but if you're working across federation, you're going to have multiple servers involved. Another thing that I've been spending a little bit of time thinking about is how to do call recording in Matrix RTC. Something interesting is that there's no solution out there today that I'm aware of for video calling that tries to do both end-to-end encryption and also call recording without just breaking that encryption. The usual way is that the call will start encrypted, but then as soon as someone hits the record button, the server is basically going to join a recording bot to your call, which is then, of course, breaking the encryption and just exporting all the media to the server. And this is kind of nice because you can get like AI transcripts and summaries this way. But what if we actually had a way that was more private? So, of course, the manual way of recording is just like ask your coworker, like, hey, can you record this call? Grab a recording of the screen and then upload it somewhere. But perhaps we could make this somewhat more of an automated process, like just have a button where you click it and then it sends some signal into the Matrix room saying, hey, I'm recording this call, so that if other people try to record, they'll know, okay, so somebody already has it covered, and then your client will automatically download all the streams and save them somewhere, and then upload it automatically back to the Matrix server. That could be a relatively simple way of getting recording working with end-to-end encryption, but there's perhaps an even more interesting way, which is what if the server was still responsible for the recording? So it doesn't matter if like any client crashes or leaves the call or gets disconnected, except the server isn't actually joining the call and decrypting all the streams, but rather the server's like recording bot is still just sitting on the outside receiving the encrypted media and saving that to disk somewhere. And then after the call, participants can come back if they have the encryption key, receive the encrypted data, and just decrypt it so the server has never actually seen it still. And here's how that might work within LiveKit's architecture. So LiveKit not only provides the SFU component, it also provides these ingress and egress components. So I tried briefly over a weekend to get this working and have a little demo. Unfortunately, there ended up being a missing piece. But the idea is you can take like LiveKit's egress service, just get it to start streaming the encrypted S-frame data out and save it to disk using GStreamer, and you'd have some like lightweight recording and playback service that the user communicates with, and that just orchestrates all of this. And then for playback, you'd take the data on the disk and you'd stream it back in through the LiveKit ingress using a combination of GStreamer and call WIP. It's this interesting thing. And then that's going to create a virtual participant, which then you could use room state for whenever you need just a lightweight mutable field with something close to like last right wins semantics. But another thing that I think will become important if you're trying to build more complicated applications is going to be relations. Currently, you can think of like when you're reacting to another event, that the reactions to this event are some kind of mutable set. And so mutable sets, I think, end up being quite useful for building more general applications. And so in the example of like a word processor, you might take a suitable CRDT for doing word processing, and then any images and diagrams that the users create while using this, you store those in the media repo, you get references to them, and then metadata about the document you could store in room state, because this is stuff that's not super critical if like two people are editing at the same time. One of their edits could just overwrite the other, and that's kind of fine. But then edits to the Word document, you might aggregate these by relating them to some kind of start of document event. And this is nice because then clients have a way to go and ask the server, give me all of the edits that are related to this document, and then you have a way to sort of aggregate them after the fact without having to page through the entire timeline, the entire history of that room. Right. And then finally, one thing that we're thinking about is if we want to build more of these applications that aren't just VoIP, we're really starting to need something like a Matrix RTC SDK. And so things that an SDK could be well suited for is like simplifying the connection to LiveKit. This currently takes some boilerplate code to get working because you have to fetch some tokens and whatever. But then just also the ability to have a more abstracted data model for how you exchange data in real time and then persist it could be nice. And so having some way to save and restore arbitrary documents from a matrix room using this sort of combination of room state and relations could be really interesting. And perhaps we could even integrate this with a one-size-fits-all CRDT such as auto merge. I don't know. But I think regardless, the future is bright for building all sorts of real-time experiences on top of Matrix. So thank you all for tuning in.
As there is no follow-up talk, there's maybe some time for questions. Are there some questions?
Right.
Yeah, so you showed the demo with a widget or extension or whatever it's now called. So I'm sure this is spec as of now, right?
So basically,
Repeat the question.
oh yeah, that's what we do always. So the question was in the demo which I've shown, if the things which were seen in that demo is spec'd. And I mean, there are different iterations to spec'd. So there's like, have their proper MSCs been written, which means that people like properly wrote out what they are doing and don't do random stuff in the background. And then there's actually making it into the Matrix spec. And making it into the Matrix spec, like none of the VoIP stuff is there yet. So that's like a longer procedure. But for like the format of the state event, what clients have to provide to understand it, and for how to connect to the LiveKit SFUs, that is all written up in MSCs. There are a couple of things how we do the ID of a membership, which is like currently in discussion. So there will be updates to the MSCs, which is like a normal MSC process. But yeah, that's the current state. So like all this could be understood by reading through MSCs, but it's not yet in the spec, so clients aren't enforced to support it. Like you will have lots of clients which don't support it, but Element Web is almost the same thing than the MSCs, except for this like membership identifier thing, which is like a super recent change. Yeah,
So you create a call nowadays by announcing your presence in it, and it's implicitly created. It doesn't mean there are what way is there to decline a call, for example. So if I call you, is there a way to say no, sorry, and then kind of stop the ringing?
Exactly. Yeah. This is something that. Oh, right. Right. So the question is, we can advertise, starting a call, but do we know how to decline a call? Say that you're rejecting a call. Right. This is one of the things that's currently still missing from our specification right now. But there are ideas floating around for this, like the primary one would be, so the ringing comes from the notify event rather than the state event where you're joining the call. So one option would be the receiving participant just takes a reaction or some other relation and says thumbs down or no or whatever, and attaches that to the notification event. That could already work. Right.
You were talking about a Matrix RTC SDK. I was thinking one way to expose that would be having a Matrix RTC bot, which could join the call, a non-human joins the call. So that all the basic plumbing of the Rust thing, so that it's a full participant, it's just not a human kind of thing. So that would be one way to codify everything that's involved to join.
Right. Right. So I suppose this is more of a comment, but just about rather than building an SDK around creating clients that interact with Matrix RTC in a special way, that it could be interesting as well to have a way to create bots that join just calls, not necessarily other experiences.
Or
and
that would be an example.
Yeah, do new things in them. Right. I think this is something we're certainly interested in having at some point in the future. Is a way to. Right. So on the just how we're right. The question how we're managing to encrypt calls. So just on the transport side, we're using the S-frame standard, which I don't know the full details of, but basically we have what the things we get are a small field in the trailer to each frame, I believe, which indicates the index of a key that you're currently using. So clients are able to potentially be switching between different keys during the same call and still have this all be decrypted seamlessly by the receiving clients, since there's information about when exactly the participant switched. And on the key management side, this is a part that's also still subject to some change. The solution we have today is just that when you're joining a call, each participant in the room will go and send the key that they intend to be using into the room as a timeline event. And this is an encrypted timeline event. And so we don't get all the nice properties yet, like perfect forward secrecy, post-compromise security yet. But we are intending to move to a solution where keys are not shared just in the room timeline, but rather directly one-on-one with the other call participants by using Matrix 2 device messages. And this is the solution where you really should go and check out Timo's full talk on the subject to get more details about what we might be going with there.
Yeah, so basically that talk then gives you what the MSC will become. So currently I think there are like multiple sections in the MSC. It will. So that's also a point which isn't like as far as you want it to be. One section is about this like timeline thing, and then we have the 2-device version, which will be much more superior, but is still in the making. And then I think one last question we had, right?
Yeah, probably yes, maybe more of a feature question, but since you showed this mouse moving around feature, have you ever thought about a feature where when you share your screen, others can basically move their mouse, because that would make it the perfect tool for like pair programming. That's always the thing that's missing. But I realize this is really hard on like Wayland apparently. So have you ever thought about it?
Yeah. So question for the stream. When we showed the mouse moving around, is there also like the opposite direction where the listener can control the mouse on my computer and actually take control over the computer?
Showing another pointer would be already fine.
Okay, or just showing a pointer. So this is very much like beyond the Matrix RTC aspect, because it's just a client needing to do it. And yeah, I think like the question already contained this is mostly a operating system security thing. And the trend is very much in the direction that this is less common. So operating systems are stricter and stricter how much applications can do with your window management and mouse control. And there could be such a thing at least drawing something on top. But like the example in the question was like pair programming. And I think there almost a more interesting solution would be what editors are currently heading towards, where you have like a proper pair programming editor session. And that could, of course, be done over Matrix RTC. Like there could be a Visual Studio Code extension joining an RTC session and then doing all the mouse movements and all the edits over RTC. And I think there are already like things that do this. I mean, like Microsoft ships their own thing. And one could maybe find a way to build a backend on Matrix RTC. So yeah, definitely multiple and lots of opportunities to use Matrix RTC for this kind of secure pair programming session. Not sure if like mouse control over screen sharings will be the final thing, but super interesting topic, definitely.
Okay, final question from you?
Oh yes.
Yeah, fast one. So you use LiveKit, right? There are multiple projects moving to LiveKit as of now. For example, Big Blue Button. I think I saw someone from the community here. Will it be possible to just reuse their platform?
Are you in this room, or do you have permission to participate in this call? This is something one could extend, but not as of now. And then you get a auth token from the LiveKit SFU. So yeah, that would totally work. Like if Big Blue Button already installs a Docker container with LiveKit, you could just additionally add this JWT token service. You just give the JWT token service a LiveKit master token, or that it's called differently, but something along those lines. And then you basically made your LiveKit service for Big Blue Button a Matrix RTC backend. So yeah, that is totally feasible to basically use the same backend solution on both.
So thank you very much, Robin. Thank you, Timo. Thank you, Will.